Would you be kind and tell me the direction vector? Go ahead.
The direction vector would be 0, 3, and 2.
Okay. I'm going to do it. I'm going to do it like this. Okay. So I'll just write it on the board. So it's going to be 0, 0, negative 2, minus 0, 3, 0. That's okay? Is that right? That's right, right? Which turns into 0, negative 3, negative 2. Just a reminder, or a new one if you haven't been here before, because the direction vector is like slope, if I point it this way, it's also going to be the same slope behind me, right? So I'm going to times this by negative 1. And I say my m is equal to 0, 3, 2. All right. Matt, what is your favorite? Can you stay with me, guys, please? What's your favorite point? 0, 3, 0 or 0, 0, negative 2?
0, 3, 0.
Perfect. So can you give me the line, please?
Yeah, I do this right.
Okay, what's your point?
So like 0, 3, 0.
Yeah. And what's your direction vector?
0, 3, 2.
Good. Now, you want to see something neat? I'm a math teacher, I think it's neat, okay? If I multiply s by negative 1, if I just say s equals negative 1, what's my point? No.
It'll blow our minds.
Probably not.
It becomes the other ones.
Okay. It's not really a wow, but it's something that should, that it should work. You should be able to find a value that gives you the other point. Okay. Sorry, okay, actually, sorry, go ahead. Because remember last week that I wanted the direction vector to be positive, right? Because it's nicer.
So, like, what if you write it?
You lose half a mark.
Seriously? What?
It's just like if you have a fraction. There was somebody here, I'm not going to mention their name on their assignment, but they had something like the square root of 16 over 4. And I marked that half wrong. Okay, because, you know, the square root of 16 over 4 is
1.
technically correct. Okay, but 1 is equal to more, 1 is more correct than that. Okay, right?
Yeah, but this just didn't bring it down. I don't know.
All right, let's start. We'll worry about fighting here on the next day. Let's, I think I want to skip this number 15. Can whoever wrote this down on the board, Luke, you, can you write it down for Monday on the test review? Because I want to do my lesson here. Is that cool? Yeah, just so you, since you know you're new here, I got good news. You have a test on Tuesday. Okay, and then you have no, next Tuesday. And then you have a midterm the Wednesday after that. Just for good news for yourself. Don't you guys remember? All right. Listen, we're on the same team. Bailey, we're on the same team. Properties of planes. All right, properties of planes. Here we go. The scalar equation of a plane.
It was funny, don't worry.
Okay, guys, can you go here, please? The scalar equation of a plane is ax plus by plus cz. I'm going to run a room. Oh no. Plus d equals 0. With the normal vector. Okay, so we're going to say the scalar equation of a plane is ax plus by plus cz plus d equals 0. With the normal vectors, n is equal to a comma b comma c. Ethan, for the people that haven't been here in 2 months, sorry, I gotta keep bugging you. It's going to be like this for the next month, just so you know. What's a normal vector? He's freezing. Somebody help him. What's a normal vector? He's freezing. no, the whole class is freezing? The whole class can't freeze. What's a normal vector? Go ahead. Go ahead.
There actually has three options.
Yes, more than that though. Normal to a, let's say I were to, hold on a sec. Let's say, okay, can I go here please? What's the normal force in physics? What's the normal force? Opposing gravity. It's actually perpendicular to the ground though, is what it is. It's not opposing gravity. So the normal force is going to be perpendicular to a plane. I'm going to get my trusty dusty meter stick out here. Okay, so if the plane is this whiteboard, okay, a perpendicular vector to it would look just like this, okay? Is there any other perpendicular vectors other than this one to this board? There are actually an infinite number of them, okay? This is one, okay, right? But the whole idea is, though, it has to be perpendicular. If it's like this is not perpendicular, right? It has to be square to the board, okay? The same thing, it can go through the other side as well, too, okay? It could also be up 1,000,000 miles high as well, too, right? It will all the way through. All right. You guys, I don't want to leave you stay in the zone, please, okay? How do you find a normal vector? They find a normal vector. Okay, guys, stay with me here. Come on, what's a normal vector? Something equals normal vector. Okay, if A dot B equals 0, whoops, I got that wrong. Try again, A cross B is the other one. Well, A dot B equals 0 will work as well too, right? But in general, for any two vectors, A cross B is going to be. Now, can anyone think of what two vectors will probably be crossing in this case to find a normal? Well, what two vectors we're going to cross? Think of an equation we're playing, which is this one. What two vectors? You guys got to wake up there.
Two direction vectors.
The two direction vectors. Thank you. Okay, we're given two direction vectors for our plane. If you cross them, that's going to give you the normal. And once you have the normal, you can put it into the scalar equation of the plane. This is more algebra. If you take a look, there's only one equation to deal with a plane.
That's still equals 0.
No, just A cross B. Doesn't have to equal 0. And that's what I was going to say. A vector. Sorry, I'm all over this here. My hair is wild too. Example 1. Says develop a scalar equation of the plane with point okay, well, this one's a class to make sure that life is good, and then we'll go here. So I'm giving you the normal, and I'm also giving you a point on the plane. Okay, so for my solution, we're going to pick X, Y, Z as any point on the plane. As point P. Okay, so we picked any point on the plane. We're going to say then, PO, we'll make a vector called POP, and I dot that with P, and that should equal 0. Oops, that shouldn't be dot P, that should be dot N, sorry. Yeah, we are, but we can also say when you dot two vectors, it should give the 0 vector as well too. So if I give you two direction vectors, stay with me actually. If I give you two direction vectors and you cross them, but also if you have a normal vector, if you have two vectors dotted and equals 0, that means a perpendicular as well too. Okay. Let's start with vector POP. What's vector POP going to be? Santa, pick on Hannah. Okay, we did this lots. If this is PO and this is P, how do we find vector POP? Close, but no, how would you find vector AB? Subtract. So this is going to be, so POP equals what? Go ahead. So what's the x coordinate of P? Right? The x, this is point P here. Sorry. What's the x coordinate of P? Good. What's the x coordinate of P naught? Okay, so x minus 4. Now I'm going to get out of the way because this is the hardest part of this question here. Is everyone okay with where that came from? We're just using two vectors to find the thing. All right, Cecilia, what's my y coordinate, please? Y how much? Y plus 1? Yeah, thank you. So where she got that one from was y minus -1. Okay, it was that. James, can you be brave and give me the z coordinate?
Z minus 3.
Good. Is anyone unsure where that came from? Please be brave and ask. Right, we picked a point on the plane, so now we have x, y, and z in our equation. So now we're going to do POP dot n. Alistair, can you remind me how you dot two equations, two points?
Multiply x values and add
Right on. Okay, so when I do POP dot n, go ahead please. Alistair, go ahead.
x minus 4 minus 3
Okay, good. Keep going. Okay, good. Keep going.
plus 3 minus 3 minus 3.
And that should equal 0. That's right, to go to 2 lines there because this is calculus. Have I told you today you guys are wonderful? You guys are tremendously smart. You're the 26th smartest people in the class. That's right. Caleb,
Oh, he's the 27th now.
Don't tell him I said that though, please, okay? His dad will watch this video tonight anyway. He'll know. Haley, can you please show your multiplication skills for me, please? Go ahead. Yeah? Keep going. Yeah? Yeah? Okay, this is looking great, Austin. This is looking tremendous. All right, but it's not quite in scalar form yet.
Whoa.
What else do I still need to do? Subtract it, so go ahead. Yeah, I see my x, I see my x is right there, I see my y is right there, and I see my z is right there, but I don't have the number. What's that number going to be, please?
3 multiplied negative 2.
This and this and this. So just like we're just using algebra here, right? So the x, the y, and the z I just moved to the left. Can you stay with me here, please? So I have negative 12 plus 5 plus 6.
Oh, negative 1.
Yeah. Is that okay? Sorry, I know it's always pressure when I pick up people, I know. And we're okay on the logic there of what happened?
Yes, that's it.
Yes.
Cool.
No, we're not okay. Okay, example. We're going to say a scalar equation of the plane.
What it is favorite suit. Vector.
It is, for sure.
Is this not example 2?
No, this is an example. This is just a written statement. No exhibit.
I have an occasion.
So I should be reading this out, but I can't play it fast. A scalar equation of the plane given through point P naught, X naught, Y naught, Z naught with normal N hat equals NX, NY, NZ is given by N1X, sorry, NX, try that now. NXX plus NYY plus NZZ plus D equals 0. Okay, so that's basically just summarizing what we just did. Now, this is the cool thing about normals. Press back, stay with it, please. This is the very cool thing about normals. Remember before we said for a plane you need a point and 2 direction vectors? Well, for a normal you just need one. You just need the direction vector. You just need one normal and a point. That's all you need to do this. Okay, which speeds things up. Remember, the whole idea of a compass is to make your life fast, not to make your life slow. Okay, so you could have taken the normal and found points based on the normal and all that stuff, and just makes things faster. Yes?
Isn't it supposed to be like NX and then X naught?
No.
No.
Because just like over here, we did the POP thing.
Yeah.
Like the X minus whatever, like, because the point P was X, Y, Z, it's going to be, the P naught is just going to be the other number for it. Okay, I'm not going to write this down here, right? Because remember that point P was equal to X, Y, Z, right?
Yeah.
So therefore, POP, you know what I mean? So that X naught, Y naught, Z naught form together to get your D. That's what happens.
Okay.
Okay.
This is illustrating computer learning classes are lacking feedback.
All right, let's try example 2 here. What do we do for time?
30 minutes.
Find the scalar equation of the plane. Through point Q, which is 2, 4, -3, and N hat equals 3, -1, and 2. All right, I'm gonna give you a second to write that down, everybody. I'll get out of your way. I want to get this fundamental thing. When I'm about to say comprendre, no, tu comprends bien.
Do you understand well?
Well, you know what I'm trying to say, okay? Are you in Spain, French? No. I visit. Okay. So we said our general equation is equal to, and this is what was getting Chris all mixed up there, was equal to nxx plus nyy plus nzz plus d equals 0. I'm not, since I think I've been through everyone twice or once at least now, what are my, to get this down initially, what's my normal coordinates I can sub in? So I don't know what x, y, z, and d are yet. But I know the other ones. Chris, go ahead.
So 3x
Yeah?
minus negative y.
Negative y, yeah?
Or yeah, minus y.
Yeah.
And then plus 2z plus d.
Okay, I'm going to take a step back because I need this to be clear and fundamental for everyone here. So once you have the normal, that's just gonna be the coefficient of your x and y and z parts here. We're sort of good? Now, can someone, sorry, Tracy, go ahead.
Okay, you just choose any point.
No,
No, not like any.
I chose these, the x, y, and z for your normal. It has to be.
Well, like, can you choose Q?
No, because that's a point, that's not a direction vector.
Okay.
Okay? All right, if I get someone to be brave and let me know how I would solve for D. Yes,
7.2.
good.
And what is D?
D is, it's called, I think it's called the discriminant. It's not the determinant. I can't remember off the top of my head. I think it's a, no, determinant, I think. Okay, so we want to say to get D sub in Q 324 negative 3. I want you guys to do that for me and get D. I'm going to pause the video and hopefully that'll take you 30 seconds. Well, this is recorded. Oh, wonderful.